Hello guys, welcome back to Maze on African Motives, still on mathematics, and for that is working on differential calculus, that is the derivatives, working on the standard form, that is the standard way of differentiating from our past exam papers. I've got a lot of questions that you're going to consider so that we see how we are supposed to answer these typical questions. So from the way that I'm saying that these are standard forms, you need a standard form like the basic derivative that you need to work on. So with the aid of our formula sheet, we are going to focus on questions like what we have got on the first part of our question, where we are given to differentiate the following in terms of x. So these are the typical questions that you might be given. So when I'm saying the standard form, what you need is let us get to our formula sheet. If you get to your formula sheet, you'll see that you are given some of the derivatives, in this case, y and dy dx. All right, so you're given a x to the exponent of n, in this case, the derivative of this. All right, so let me try to indicate on this part is given as na x to the exponent of n minus 1, meaning to say we are simply multiplying by the exponent, then we subtract 1 on the exponent. These are the basic ways that we're talking about. So if you work with these formats, what you need is to have the format that is presented on the left-hand side. With this format that we have, then we are going to check the resultant depending with the format that you're given. These are the corresponding derivatives that we are going to have. And also, in addition, here we are going to see that in addition, let me say this way. If you are given, let us just take an example of these derivatives. I want you to see that these are not actually presented in the exact way, manner, or the exact way that you expect it to be. We might be given a condition. Let's just take an example of this part here. This is ka to the exponent of x. But if you are given a condition, let's say to differentiate 2 times 3 to the exponent of 4x like this. If you check what you are given, we do not have this part of a 4. It's not presented on our, it's just x. So if we put it like this, it is going to give us a lot of challenges to say, what if it is a 4x now? What if it is a 5x? What if there's another number that is there? How are we going to have this now presented? All right, so here I'm just going to add this way to say, if you are given this as ka to the exponent of f of x, let's say a to the exponent of a function that has got x in this case. So this is going to give us, all right, so let me point it this way so that we can properly see our answer. So this is going to give us k times the first derivative of this function, your f of x. So it's going to be the first derivative of our f of x times a to the exponent of f of x, in this case, times the ln of our base, which is the ln of a. So this is what you're going to have at the end. All right, so it is the same thing that you're going to have throughout on our derivatives. The same here. On our sign is sine x. What if it is sine 5x, or it is sine 7x, sine 10x? How are you going to present when it is a trig? All right, so for a trig function, we might expect to have something of this nature. Let us say sine ax. It's a linear expression that we are referring to when we are saying ax, the linear part. All right, so this is going to give us a cos. Sign changes to cos, which is fine, but just take note that the number that is going to multiply here is going to, if it is a linear expression, then it is going to give us a cos ax. So it is the same throughout, or this cos, the tan, the cot, whatever that you have. If this is sec ax, the derivative here, we are going to have a sec ax tan, we are going to have the a also on this part. So this is what I'm trying to say. So these are some of the adjustments that we need to make on our formula sheet as we are answering our questions, because it's not given as it is. And also to add this part of a log, the derivative of a log, just a normal logarithm. Let us just say we are given the derivative with respect to x of a logarithm, which is k, the logarithm of f of x. Let's take it as f of x in base of a. So when you are differentiating a log like this, we are going to have k times the first derivative of f of x. So this is k times the first derivative of f of x, everything over the ln of a, which is our base in this case, times f of x as it is, which is our original function. So this f of x is our original function. So you can even start with this part, f of x here, ln of a, which is fine. So this is your original function, which is this f of x, then the first derivative, depending with the function of x. This is how you can actually differentiate a log function. All right, so let us quickly rush through our questions and see how can you apply these derivatives together with the formula sheet that we have so that we can understand typical questions. So this is what we have on our first question, where we are given differentiate the following in terms of x. So like I was saying, the format first you check is 3 times pi to the x in a standard form. Do we have this in a standard form? So this is the same thing as this part. So it's in a standard form. If you check, it is the same as ka to the exponent of x. This is in a standard form. So there's nothing that you're going to do there. We are going to simply differentiate direct. All right. So this is what you do. You check each and every part. So let me go through these together, and also to check it's with respect to or in terms of x. So it's y with respect to x, meaning to say any other part that he has got where we do not have x, that part is simply a constant, and the derivative of a constant gives us a 0. So this part has got x. Okay, so let us have this in a standard form before we differentiate. All right, so the first part, like I said, is fine. The log also is fine. But if you check here, we've got a 1 over tan. On our derivatives, we do not have 1 over tan. We've got the derivative of tan, not 1 over tan like this. So we need to rewrite in the normal format. Also, the square root of x, 3 over sine. These need to be rewritten so that we can be able to differentiate them properly. So let me have this as y is equal to 3 times pi to the exponent of x plus a third, the logarithm of x in base of 3. Then what are we going to do in this case? Remember from our trigonometry, 1 over tan, it simply gives us a chord in this case. If you're given 1 over tan, that's a chord. So this is 1 over tan x, which is a chord. Remember, this can be written as, from this part, it can be written as 1 over 3 times 1 over tan x. So 1 over tan x, which is cot x. So meaning to say, this is going to give us minus 1 over 3 cot x in this case. Take note, we haven't started differentiate. We are just rewriting so that we can be able to differentiate. So the square root of x is, or can be written as to the exponent of I have from our laws of exponents. Here we've got the same thing. 1 over sine of x from our trigonometry. 1 over sine x simply gives us cosec x. So this is going to be 3 cosec x in this case. So you're supposed to ought to understand also our trigonometry so that we can be able to simplify first before you differentiate. All right, so this is what you have. Before you can differentiate, we have rewritten this given equation in a way that we understand from our standard way or our standard derivative. So now we can differentiate. So dy dx, that is the derivative of y with respect to x. All right, so this is 3 pi to the exponent of x. Like I said, this is the same as writing from this manner here. Let me show you from your formula sheet. So this is the same as ka to the exponent of x, which is ka to the exponent of x ln of a, which is the base. So we are going to have our k being the number multiplying, which is this one. So this is going to remain. This is just x here, not 2x, not 3x. This is 1x. So this one is not going to give us a challenge. So we are going to differentiate direct. Like I said, it's going to be 3 times pi to the exponent of x in this case times the ln of the base, which is the ln of pi in this case. All right, so this is what you're going to have. And we can just leave it like that. We move on to the log. So this is going to be plus. We move on to the log. Remember the derivative of a log from the presentation that I had. Okay, let me just try to write it here. Remember I said whenever you are differentiating a log and we have got given this as a k log f of x in base of a in this case. So this is a derivative with respect to x. We said for a log function, this is going to give us as, all right, sorry for that. So for a log function, this is going to give us as k times the first derivative with respect to x over the ln of a times the f of x. So take note in this case, what we have, it's k time, which is k times the first derivative of this part here. So let us try to have it aside. So we are going to have, this is our k in this case, okay, which is a third. So we are going to have our answer as a third times the first derivative in this case, which is our f of x, which is 1. So this is x. So the derivative of x, this is 1. Everything over ln of a, which is going to be the ln of the base, our base in this case, which is 3, times f of x, which is our original function, which is in this case, it's x. So this ln 3 times x is same as x ln 3. So it's x ln 3. Okay, x ln 3. So if you are to simplify, we can see that here, guys, a third times a 1. This is same as 1 over 3. Everything over, like I said, ln 3 times x is same as x ln 3. So if you're dividing, what simply means the 3 is going to also affect here. Okay, so meaning this is going to give us at the end, we are going to have 1 over 3x. So it's going to be 3x ln 3. All right. So instead of having a fraction and a fraction, you can divide. Remember from our division of fractions, we can apply that from our Math N3, from our mathematics N3 there. All right. So this is how we can find the derivative of each and every part that you're given. So you need to work each and every part. All right. You move on to the cot. All right. Remember the derivative of a cot gives us cosec squared. So this is going to be a cosec squared from our derivatives here. We've got cot x. So this is just x, which is negative cosec squared. So meaning to say we are going to have a negative cosec squared in this case. But now with a negative that is already there, it's going to be negative, negative, which is a positive. So it's a positive, a third cosec squared x. So like I said, cot, it's a cosec squared. All right. The x to the exponent of a half is from x to the x to the exponent of n. So we are following the concept of ax to the exponent of n. It's x. So we drop the exponent, we subtract 1 on the exponent. This is the basic derivative that we are supposed to know in our syllabus. So let us do it this way. We are going to drop our exponent here. We multiply by the exponent, which is going to be negative half x to the exponent. We subtract 1 on our exponent. So it's a half minus a 1, which is a minus half. So what are you going to do? You can simplify further. Remember, x is raised to the exponent of negative half. So this is going to be this negative 1 over 2x to the exponent of a half, which simply the square root. Remember, the exponent of a half is the square root of. So that means we're going to obtain negative 1 over 2 x to the exponent of a half, which simply means the square root of x. In this case, we are going to obtain negative 1 over 2 square root of x. All right, we move on to the cosec x. So what is the derivative of cosec x? Again, we are given this on our formula sheet. So you can just check your cosec x in this case gives us cosec x is going to give us negative cosec x cot x. So we are going to have negative cosec then times cot. But if we check here, there's a number that is already there, which is a 3. So it's a plus 3. But our answer, we said it's a negative cosec. So it's negative times a positive, which is going to give us a negative. So we're going to obtain negative 3 cosec x cot x. We saw that the derivative of cosec, it's cosec, negative cosec cot. All right, so this is your final answer. As you can see, we have differentiated each and every part that you're given. So this is how you can play around your derivatives. You simply need to understand the format that you're given. From what you're given here, which is the exact form that you can rewrite first, then you can find the derivative by after rewriting whatever that you are given on your question. All right, so let us check the other part of our question. Like I said, you've got so many questions that you're going to consider. That's another question. Differentiate the following in terms of x. Again, it's in terms of x. So all you need is to have it in a basic format. So if we check the previous part, we can see that the first part that we have here, we need to change this negative 1 over x 3 to the exponent of -5. We take this on top. So whenever we take this on top, we introduce a negative. So it's a negative already. So it is going to be a positive on top because we introduce a negative. So it is going to be 3 to the exponent of 5x in this case. All right. What about the trig that we have here? So here we're just rewriting, guys, from our, okay, let me take it this way. 1 over x to the exponent of a is simply taken as x to the exponent of minus a. So if we are given as 1 over x to the exponent of minus a, as we need to introduce a negative, just like this part here where we introduce a negative. So this is going to be negative is going to be x to the exponent of negative a, which gives us a positive a. So that's why we are having this as a positive 5 in this case. All right, so that's from our laws of exponents. Now we've got a trig part, and on your trig, it means you have to work with your trigonometry in this case to simplify this part. We can differentiate this direct. Remember, we are using the basic, the standard way. So we have to ask ourselves, like, which part can we use, or what can we do with our trig? Remember, from our trigonometry, if we are given the cos of 2x, this one, we've got three identities actually for cosine of 2x, which is equivalent to cos squared x minus sine squared x. The same cos 2x can be equivalent to 2 cos squared x minus 1, which is equivalent to 1 minus 2 sine squared x. These are the three identities which can be used in place of cos 2x. But which one can we use in base? Because we have a fraction in this case. That's why we are supposed to think about the numerator, because our fraction in this case, the denominator is an expression. There are two terms that are being added together. So the cosine of 2x, the best identity that we can pick in this case is the first one. Since here we've got sine and cos, we also have sine and cos on our identity. Remember, sine x plus cos x is same as cos x plus sine of x. So this is just one and the same way of writing. All right, so that means we can take it this way. All right, so we can take it this way here. We are going to have this cos 2x as cos squared x minus sine squared x. Everything over the sine of x plus the cosine of x. Okay, if we simplify this further, we are going to see that this here on top is simply from our difference of two squares. Remember, guys, this is not part of our derivative. This is what you need to know from your trigonometry there. We need to work on it as much as you can. Okay, let me just explain this part. The cosine squared minus the sine of squared is simply taken from your difference of two squares, a squared minus b squared, which simply gives us a minus b, remember, a plus b. So this is what we have. The cosine squared, the sine squared. So meaning to say we shall have two brackets with the cosine of x minus the sine of x, just like a minus b, a plus b, into the cosine of x plus the sine of x, like this. But everything is over the sine of x plus the cosine of x, which can simply cancel because these two are the same. Sine x, cos x, sine x, these two are the same. So meaning to say we can cancel this part and this part. We remain with cos x minus sine x. So this is what you're going to remain. But take note, there's a plus that we have. So plus times the cosine of x minus the sine of x does not affect anything. Plus times cosine of x, we are going to have plus cos x, plus times minus sine x, this is going to be minus sine x. Take note, guys, we are still rewriting our expression so that we can be able to differentiate. So as you can see, for you to understand diff a lot, also work with the previous topics and work with your trigonometry or exponents. It's a combination of topics in one topic actually that you need to know. All right, so let us move on to the last part, which is a ln pi. This one, there's nothing that we can do. We're just gonna rewrite as it is. So this is plus ln pi. So ln pi, it's a constant, it's a number. Pi is a number. So meaning to say ln pi is a constant. And we know that the derivative of a constant, like I said, gives us a 0. All right, so this is where we are. We have managed to rewrite our given expression terms that we had in a way that we can be able to differentiate it. Now we can differentiate y with respect to x. All right, so 3 to the exponent of 5x, we are back to that part. Remember what I was saying now, if there is a 5 like this, it affects a lot. I want you to check on that presentation that we had here. We're saying if it is k here, k a to the exponent of f of x, it is going to be k times the first derivative times a to the exponent of f of x times ln of a. This is what we have in this case here. We are given our number as, all right, so let us check here, 3 to the exponent of 5, meaning to say the constant here, there's a 1. It's 1 times like this, 1 times 3 to the exponent. This is our a. This is our f of x here. This is your a. This is your k, your constant, which is 1. So as we saw that, we are going to have k times the first derivative with respect to x times a to the exponent of f of x times ln of a. And our constant in this case is a 1, and 1 does not affect. So we're going to the constant, we are not going to work with it. We need the first derivative, which is 5x. The first derivative here for 5x is going to give us a 5. Remember, if you are given the derivative with respect to x of ax, which is a linear expression, gives us a. The derivative with respect to x of a constant, which is a, gives us a 0. So a constant gives us a 0. So here we are given ax, that is 5x. So meaning to say we are going to obtain 5 in this case. This is the first derivative times a to the exponent of f of x, which is this 3 to the exponent of 5x. So it remains as it is, 3 to the exponent of 5 of x times ln of a, which is ln of the base, which is 3. So it's going to be ln of 3 in this case. All right, so that is it. We have differentiated this part. You can just leave it like that. All right, we move on to the cosine of x. This one is direct from your formula sheet. That is negative sine x. The sine of x gives us cos, but there's a negative here, so it's going to be negative cosine of x. Then, like I said, ln pi. Pi is a constant. The derivative of a constant gives us a 0. So this one is going to give us a 0 at the end. All right, so this is what you're going to have at the end. That is 5 times 3 to the exponent of 5x times ln of 3 minus sine x minus cos x plus a 0. So what you need, guys, is to understand how to rebranch this typical question that you're given, how to separate it in a way that you can differentiate. You can't differentiate by just looking into the question, you give us the answers. It's not like that. You need to follow the stages, stage by stage, separate your trig in a way that you properly understand. Then from there, you can be able to differentiate each term. All right, so there's another question. In fact, so many questions that we're going to have. Another question here we are given, differentiate the following expressions. That's definitely y with respect to x. All right, so let us see if we can be able to differentiate direct, which is impossible here, because if we check, again, we've got a trig part. The trig part, again, that need to be simplified. Different from a condition that I wanted to check the previous question that we had. Let me just show you the previous question here. It was given as cos 2x over sine x plus, if you take cos, we are adding, we've got an expression, 2 terms in the denominator here. So what you can think about is to work from the numerator to find from the numerator. But if you check the next question here, we have got a single term in the denominator here, we've got a single term. When you are given a single term like this in the denominator, there's a single term. What you do is that think of separating your fraction into 2 terms or 3 terms or whatever terms that you can get from this concept A plus B over C. I explained that this is same as A over C plus B over C. If you are given a single term, that's a single term in the denominator, you can separate that way. So meaning to say, from the sine 2x plus 1, these are 2 terms in the numerator, but in the denominator, there's a single term. So meaning to say, we can separate this as the sine of 2x, everything over the cos of x, plus a 1 in this case over the cos of x, just like A over C, A over C, B of plus B over C. So that is the same concept. Once you are at this stage, you can simplify in whatever way. Remember, once you've got sine 2x separated like this, you can apply, remember, from your compound, that is from our double angles. From our double angle identities, the sine of 2x is same as the 2 sine x. So this is same as 2 sine x cosine of x. So meaning to say, we can rewrite sine 2x as 2 sine x cosine of x, everything over the cosine of x, plus from our identities, from our trig again, 1 over cos x. This one is the same as sec x. So if we can see from the first part, cos x and cos x will cancel. You remain with the 2 sine x over 1. So this is going to give us y is equal to 2 sine x plus sec x. From 1 over cos x, we obtained sec x. So this is going to be plus sec x. So this is what you're going to obtain from this part alone, this part, before even differentiating. All right, so let us move on to the next part of our question and see if it is a normal format that we can actually be able to differentiate. This is in a normal format, but just that we can just write as 1 over 14 separate so that we can properly see what is happening here. So this is same as 1 over 14 times e to the exponent of 7x. All right. Negative 2 to the exponent of x. This one, there's nothing. Same here, 1 over 4. So it's same as 1 over 4. So you can write as plus 1 over 4 times pi to the exponent of 3x minus 2b plus a half ln x. So these ones, there's nothing that we can do. We just rewrite as they are. They are already in a format that we can differentiate. So what we just needed was to rewrite our expression in a way that we can differentiate, because once we have got this way, then we think of our standard derivatives. What is it that we see about sine? Remember, the derivative of y with respect to x for a sine gives us a cos. We saw that. So this is going to give us 2 cos x. Then we have got sec x in this case. So take note, sec x is going to give us sec x tan x. Okay, let me just show you on this part here, if we still have that one here. Sec x, it's sec x tan x. So that is what you're going to have for sec x in this case here. This one is going to give us plus sec x tan x. All right, we are back to the condition, this one that we talked about, of a number raised to a certain exponent, a to the exponent of. So this is e, which is a special number that we have, but the concept does not change. Remember, we said we are going to have the derivative of which is going to be k times the first derivative with respect to x times a to the exponent of f of x ln of a. So if we check from this part, our k in this case is 1 over 14. So we're going to have 1 over 14 times the first derivative with respect to x, which is 7x. So if we differentiate 7x, that will be a 7 times, in this case, we are going to multiply a to the exponent of a, which is this e. So it's e to the exponent of 7x times the ln of a, the ln of the base, which is the ln of e. So if you take note, ln e is equivalent to 1. From our logarithms, ln e is equal to 1. So if ln e is equal to 1, it simply means here there's a 1. So if we multiply 1 over 7, 1 over 14 times a 7 times a 1, this is going to give us 1 over 2. So we are going to obtain 1 over 2 e to the exponent of 7x. All right, so we have differentiated this whole part here. Which is okay. Instead of erasing, I can see that we have got the same thing here. This is the same thing that we have again on this part here, 2 to the exponent of x. So this what time we do not have just like 1 time. So it's going to be minus 2 to the exponent of x times the ln of the base, our base in this case, which is 2. So that's ln of 2. All right, the same thing on this part here. This time there's 3x. So this 3 simply multiplies here, just like 7. 7 multiplies here. So it's 3 times 1 over 4, which is going to be 3 over 4 times the base to the exponent of this remains as it is. So it's pi to the exponent of 3x times the ln of the base, just like ln 2. So this one is going to be ln pi. So we are going to have this as ln pi like this. Okay. So that is the derivative that you're going to have from this part. Then we move on to negative 2b, which is not having, there's no x here. So it means this is a constant. And I said the derivative of a constant, it's a 0. So this one is going to give us a 0. All right, then we move on to a half ln of x. Remember from your formula sheet, the ln of x, its derivative gives us 1 over x. So it simply means we are going to have 1 over 2 times 1 over x. 1 over 2 times 1 over x is 1 times 1, which is going to give us a 1 over 2 times x, which is going to give us 2x in this case. So this is plus. So we are going to obtain plus, in this case, 1 over 2x. All right. So as you can see, this is going to be our final answer, the one that you're going to have at the end after you have differentiated everything. So all you need, as we can see, are the steps, the stages from the first part. Try to rewrite in a way that you understand. Do not rush. Rewrite in a way that you properly understand. Once you've rewritten the question that you in a way that you understand, now you can find the derivative of each and every term that you're given. That is how we can play around with these typical questions. All right, so let us check here if we have got other part. If you check on 1.3, another question that we are given, it was to differentiate in terms of y in this case. So if we check here, this is an expression that we are given. It's in terms of y, but we are given that if x is equal to, take note what we have this time. This is of x. So, but the concept does not even change. What we need to consider now is x with respect to y. So which means we are supposed to find a derivative of x with respect to y like this. If you are given an expression y is equal to 2m cubed plus 3m plus 7, then expect dy dm. Y with respect to m, that's dy dm. Here it's x with respect to y, so it's dx dy. That is how we can play around this. All right, so meaning to say the format is the first thing that you need to just check on and see if we have got the same format. That is the basic format that you can play around with, which is here, everything is fine. The ln of minus y, we can simply differentiate this. So we are going to rewrite as ln of minus y, in this case, minus 4a to the exponent of 3, which is fine, minus 2 pi cos y, which is also in the exact way. Okay, let's check this ln here. I've got ln y to the exponent of 3 over 4. From our laws of exponents, we understand if there is an exponent on a log, which is a ln is a log. So if we understand that any log m can be written as any log m to the exponent of n, it means we can even drop this exponent to multiply the log just like any log m. So this is the same condition. We are going to drop this exponent first to multiply our log. So this is going to be minus 3 over 4, the ln of y. Take note, we haven't started differentiate. We are just rewriting in a way that we can be able to differentiate. That is from the laws of our logarithms. Here from your laws of exponents, you can also simplify. This is same as square root of 4y. So square root of 4, we know square root of 4. So this is going to be 1 over 2. Square root of 4 is 2, but we do not know the square root of y. We do not know the square root of y. So y is going to remain as to the exponent of a half to represent the square root of y. Then like I said, it must be written on top. So the moment we take this on top, remember what I said, it takes a negative. So that means we're going to have 1 over 2 times y to the exponent of a negative half on top. So that is what you're going to have here, 1 over 2 times y to the exponent of a negative half. So like I said, this part we haven't started differentiating. We're just rewriting in a way that we can be able to differentiate. Now we have got x and y that we can properly see. So we can find the derivative of x with respect to y in this case. Following the same procedures where there was x, but only that there is a y in this case. All right. So what is the derivative of ln? Like I said from the previous part, ln gave us 1 over x. So this is ln minus y. So it's going to be 1 over y. Instead of 1 over x, it's going to be 1 over y. So we're going to obtain 1 over y like this. All right. As long this is a linear expression, whether it's a negative is a positive, 1 over x. So we simply say the derivative with respect to x. Let's say we are referring to, with respect to x in this case, of linear x, a linear expression, only for a linear expression. This is going to give us 1 over x. As long this is a linear, that is the most important part, that it's a linear term. The highest exponent is 1. Let us take it that way. Okay, so that means we are going to obtain 1 over y in this case. Then we have got 4a to the exponent of 3, which we do not have y in this case. So this becomes a constant. And we know that the derivative of a constant gives us a 0. So this one is going to give us a 0. Okay, minus 2 pi cos. Remember, the derivative of cos gives us a negative sign. So we are going to have a negative and a negative, which is going to be a positive. So it's positive 2 pi sine y in this case. All right. Then again, we have got a ln, just like the previous part. I said as long ln, it's a linear expression. It gives us 1 over that late, which is 1 over y in this case. So here we've got negative 3 over 4, which was a constant, times the derivative of ln y, which is going to give us 1 over y. So if you multiply, we are going to have negative of negative 3, 4 times y, which is 4y in this case. So this is going to be negative 3 over 4y like this. All right. So that is what you're going to have on this part. All right. Then the next part, we are given half y to the exponent. So this is same as x to the exponent of, where you drop the exponent. So this is a half times negative half. You drop this exponent, a negative half like this. Then y, you subtract negative 1 on your exponent. So that's a half times a negative half. So this is going to give us negative 1 over 4. All right, let me just write, before I write the final, let me simplify. So this is going to give us negative 1 over 4 like this. Y to the exponent of negative 3 over 2. If you subtract here, you are going to obtain negative 3 over 2. But from our laws of exponents, we understand that y cannot be written as a negative exponent. We can write this as negative 1 over 4 is already in the denominator. So we are going to take y to the 4, which is in the denominator. So that's y to the exponent of 3 over 2 in this case. So this is 3 over 2. 3 over 2 simply means the square root of, like this, 1 over 4, the square root of y to the exponent of 3. That's here from our laws of exponent. X to the exponent of a over b means the bth root of x to the exponent of a, like this. So that is what we can have our final answer as. So we can have our final answer in this case as the x dy. Take note, it's a derivative of x with respect to y in this case. So this is what you're going to have at the end. So let us try to have as much questions as possible before our exams that we are facing. In the meantime, all you need is to work on more questions, more revisions, which can actually help us a lot. All right, so I actually need this part. Okay, so let's check another part that we are given. So this one, I think with the information that we have talked about, now we understand this part. Here we are given differentiate the following in terms of x. Y is equal to ln x over 4 minus 3 quarters. So this one is actually in a normal format that we are used to. Like I said, this is same as 1 over 4. So remember, the derivative of ln x gives us 1 over x. So meaning to say the derivative of y with respect to x, we are going to have 1 over 4 times 1 over x. So that will be 1 over 4 times x, which is going to be 4x. All right, so this is in a normal format. That is why I'm simply differentiating direct like this. Okay, let's talk about ln. The chord. What is the derivative of a chord? From your formula sheet, chord gives us negative cos x squared. So this is negative cos x squared x. But there's already a negative here, a negative 3. So it's negative 3 times a negative, which is going to give us a positive 3 cosec squared x. All right. Then we've got 7 to the exponent of, that is, we are back to that derivative of a to the exponent of f of x. If we are given k times, where we say the derivative of this is going to be k times the first derivative with respect to x times a to the exponent of f of x times the ln of a, which is the ln of the base. So here the constant is just a 1, it's 1 times. So that is same as there is a 1 there. So we're just going to start with the 7. So it's plus the first derivative in this case of 3x. We are talking about 3x. What is the derivative? The first derivative of 3x, which is going to be 3 times a to the exponent of f of x, which is this number, to the exponent of 3x. So that will be 7 in this case. So we are going to have times 7 to the exponent of 3x times the ln of the base, which is the ln of our base, which is 7. So this is going to be times the ln of 7. All right, so this was a direct question that we had in this case. Okay, this was just a direct question that we had. All we need is to work on more questions, more revisions, which can actually help us to understand our derivatives. How do they ask these questions? How are we supposed to answer those typical questions the way that it is given? That is what you need to know or to understand in this case. All right, so let us see the other part that we are given. We have got another part again, differentiate with the following with respect to x. All right, so let's see, guys. These are a lot of questions that we can actually work on, revise and see. So this is same as this was 1/4x to the exponent of -4, negative cos x. Okay, this is what we have, guys. Let us see how can we play around this part. Okay, so the first part, okay, 1/4, this can be differentiated direct, so there's nothing that we're gonna do. So let us just write in this case as it is, that is y is equal to 1/4 x to the exponent of -4. All right, then here we are going to subtract. Take note, whatever that you're going to subtract here, we have got, remember I talked about this condition to say if we've got a single term on a trig and you've got a single term in the denominator, therefore you can think of separating your fraction, in this case, your fraction. So this is going to give us a negative. Remember, there's a negative here. This negative is not for cos. It's for everything that you're going to get here after expanding whatever that you're going to get. All right, so you're going to have it as a negative. So you're going to separate fraction, the first term over this, the second term over this. I think I explained this from the first term. So this will be cosine of x over 2 sine of x, like this, plus 3 tan of x, everything over 2 sine of x. Everything is separated to with sine 2x. Okay, so here we can play around with our identities. Remember that cos over sine from your identities, it's cot. So this is same as we've got 1/2. So it's negative 1/2. So we've got 1/2. But cos over sine, this is what we want, a cos over sine, which is cot x. If it is sine x over the cosine of x, this is the one that gives us tan. This one, sine over cos, is tan. But the reverse now, it's going to give us cot x. All right, so this is what we are going to have. What about this part here? We're given 3/2, so we're going to have plus 3/2. In this case, this one, let us just rewrite as it is, plus 3/2. But if we check, there is a tan x divided by a sine, and I said tan, it's same as sine x over the cosine of x being divided to this sine x. So divided, it simply means like this, divided to sine x, which is same as sine x over 1. So remember, you introduce multiplication. So this will be sine of x over the cosine of x times 1 over the sine of x. So the moment we have this, the sine of x and the sine of x can cancel, meaning to say you're going to remain with 1 over cos x. So this will be 1 over the cosine of x. And I explained that 1 over the cosine of x is same as sec x. So meaning to say this whole part of tan x that we see here, when it is simplified on this part, it is going to give us this as a sec. So this is going to give us as a sec on the last part here. So that is the most important part. You have to simplify everything in a proper way. So here, everything gives us a sec. So we're going to have this as we said sec x, all right? So we are going to have this as sec x in this case from tan over sine x. So meaning to say, with the negative that was outside of the bracket, now we expand with the negative. So it's negative times half this, negative times everything that we have. So let us multiply by negative and see what you're going to obtain. Negative times half, negative times a half cot. So this will be negative half cot x, negative times a positive. Take note, this is a positive here. So if you multiply by a negative, it is going to give us a negative. This is negative 3 over 2 sec x in this case. All right. So that is what you're going to have from this simplification of this part alone, this part in a basic way from our trigonometry. Then now we move on to this part of our ln. We've got negative ln e to the exponent of negative x. So it's a log. Ln is a log. So if ln is a log, it means that we are going to apply this as we are going to drop our exponent. In this case, we are going to drop our exponent because ln follows the concept of a log. So knowing from this, remember what I said from this log, applying, just dropping the exponent here because we are saying it is same as a log. So we're going to drop this exponent. Take note what's going to happen here. There is a negative already, so it's going to be negative times negative x squared ln e like this, which is negative, which is a positive x squared ln e. But ln e is same as a 1. So meaning to say we're just going to remain with x squared times 1, which is x squared. So that is what you're going to have at the end here. Log, ln, it's a log. So whenever you have an exponent, you drop that exponent to multiply the log. So that is what is happening. So, but you remain with ln e, which is ln e is same as a 1. So meaning to say this whole part, they are just trying to say this is same as x squared, but look at the way that they try to present it. Okay. Anyways, then the last part, there's nothing that we can do here. It's already in a way that we can be able to differentiate it. We can differentiate this part direct. So we're just going to rewrite as it is. Okay. So we have rewritten this whole expression or the whole equation that we had before in a way that can be differentiated, the way that we understand. Now we can differentiate each and every term y with respect to x. So let us differentiate. That is the derivative of y with respect to x in this case. All right, so let us start with the first part. Remember here, we drop the exponent, we subtract a 1. This is of x. So if we drop our exponent, it's 1 over 4 times a negative 4. So this is going to give us negative 1. Then we subtract here negative 4, negative 1, which is negative 5. So here we are going to obtain negative 1 x to the exponent of negative 5, which is negative x to the exponent of negative 5 like this. But knowing that the negative here on the exponent, we can remove it as 1 over, or you can leave it like that. So here you can choose to leave it like that as negative x to the exponent of negative 5, or you can write it as negative 1 over x to the exponent of 5. So you can leave it like that, or you can write in this manner. You just choose which one to leave your answer as. All right, so that is the first part. Then we move on to this part where there's cot. Cot, we have it on our basic derivatives. Remember, cot gives us negative cosec. So here we are going to have negative, which is a positive. So we're going to have positive half cosec squared x. So that will be a cosec squared x in this case. Then we've got a sec in this case. Remember, the derivative of sec, we talked about this before. We have it on our formula sheet. This is going to give us sec x tan x. So, but there is a negative 3 over 2 that we have. So it is just going to multiply. So it is going to be negative 3 over 2 sec x tan x in this case. X squared, just like x, here there's x. So you drop the exponent. So here there's a 1. So it's 2 times 1, which is going to be 2x to the exponent of, we subtract 1. So it's 2 minus 1, which is 1. 2x to the exponent of 1 and 2x simply the same. So you can just leave it like that. All right, we are back to the e in this case. Remember, for e, we said it is going to be the constant first, -3 times the derivative of f of x, in this case, our function, which is -7. So we're going to have -7 times the base raised to the exponent, which is e to the exponent of -x times the ln of the base, which is the ln of e. I talked about ln before. So here we can combine -3 times -7, which is +21, and ln of e is equal to 1. So it's 1 times this one, which is going to be a positive. Ln e, you can choose to leave it like that, but just know that ln e is a 1. So it's 1 times these 2, which is going to be a positive 21 e to the exponent of -7x. So this is what you're going to have at the end. As you can see, yes, we have managed to differentiate each and every part. Each and every part that you're given, we've managed to differentiate, which is the most important part. Rewrite in a way that you understand. If you understand as it is here, which is very, very complicated for most of us. So please do rewrite your derivatives, your given equation. Then you can differentiate each and every term depending with the basic derivative that you're given, and also working with your formula sheet, which is most important. All right, let us check the last part of our question, where we are given again, differentiate the following with respect to x. With respect to x, just like what we had before. So what are we going to do? If we check here, there's just a few things that we just need to take into consideration. The first part is actually fine. 5 tan x, we can differentiate this. So we're just going to rewrite as it is. 2 to the exponent of x, we can differentiate this, going to rewrite as it is. But let's take a ln. Remember, I said ln is same as a log. You treat ln just as a log. So there's an exponent here. So we are supposed to drop our exponent first. So this is going to be -4 ln of x. All right, then a trig. So a trig, guys, you see the trig part here. Again, we are back to the trig. And we've got a single term in the denominator. And I said, whenever there's a single term, divide by that single term each and every term. So this will be 4 over the sine of x plus 3 cos x over the sine of x, like this. All right. Whereby we know that 1 over sine of x, this one, the 1 over sine of x gives us cosec. So we are going to obtain 4 cosec x. Then here we are back. I explained this before. That's cos over sine. This one, cos x over sine x, it's a cot. So we are going to have 3 cot x, like this. So that is what you're by just rewriting, not different, rewriting. And also take note of this sign that is outside, meaning to say we are going to affect everything by +1. But a plus does not affect, because here it's going to be plus times 4, which is simply going to be 4 cosec. Okay, this is cosec, sorry, that is cosec x plus times a plus, which is simply a plus. So this is going to be +3 cot x. So we have rewritten this part here. We have rewritten our derivative in a way that we can be able to differentiate. Now we can differentiate each and every term that you're given from our formula sheet. Tan of x is there, so we can differentiate this one. All right, so we are going to have the derivative of y with respect to x. Let me just try to change it this way. All right, let me just remove this part. So we're going to have the derivative of y with respect to x in this case. All right, so I said that derivative of tan from our formula sheet, this is sec squared. So we're going to have 5 sec squared x. All right, so this is going to be 5 sec squared x, then plus 2 to the exponent of x. We are back to a to the exponent of f of x, k times this. So this one is direct here. We are just going to have 2 to the exponent of x times the ln of the base, which is the ln of 2. We do not have a number like 7 or 8, so then we are just going to have 2 to the exponent of x, ln of the base. All right. Remember the derivative of ln x, ln, I said it's 1 over x. So if it is 1 over x, but there's a number that is there, which is -4. So you're going to multiply by -4 over 1. So it's -4 times 1, which is going to give us -4 over 1 times x, which is going to give us x. All right, then we move on to cosec. Remember, cosec, we have it again on our formula sheet, which is negative cosec cot x. But there's a +4 that we have. So that will be a negative and a positive, which is going to give us -4 cosec x cot x. We are given this direct on your formula sheet also. Then the derivative of cot, you're also given on your formula sheet, which is negative cosec squared. But there's a +3, so it's going to be -3 cosec squared x. So this is the derivative that you're going to have at the end. So each and every part is going to be marked. Each and every part is going to be marked in this case, meaning to say the questions are going to be 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. That is 1, 2, 3, 4, 5. That is how they mark these questions. So make sure that each and every derivative, you make it right. And work on your trig so that it becomes easier for you to simplify expressions or terms of this nature before you differentiate, and also your logarithms like these ones before you differentiate, and also working with your exponents just to relate your exponents and logarithms together with the derivatives that can actually help. Okay, guys, that's what we had from Mason African Motives, working on mathematics. And for derivatives, that is the basic approach of derivatives, the standard way or the standard forms of our derivatives from our formula sheet. So we shall meet again talking about the chain rule, talking about the product rule, the quotient rule, the applications of derivatives, finding maximum and minimum values, the issue of point of inflection. So let us tune in to Mason African Motives. Don't forget to subscribe if you are new, and also to share our videos to your friends and colleagues so that they also can benefit from this platform. But for now, that's it, guys, from Mason African Motives. Till we meet again.